Hi, welcome to the exercise for lecture number 8 of BIO1026, oxidation and reduction. We will start with the first exercise, but basically tell us, write the products of the following reactions. The first is, we have benzaldehyde, and we react with sodium borohydrate. Remember the mechanisms? Okay. The electrons that are forming the boron-hydrogen bonding is attacking the carbonyl group. Remember that this carbonyl group is polarized because the oxygen is more electronegative than not the carbon, and what we get is this intermediate. Okay, that after protonation, what we get is the alcohol. Then we oxidize, okay, and what we get is, first we oxidize to aldehyde and then to acid, and then what we do is add methanol in acid media. Okay, remember how it's working. Okay, and what we get is the formation of the ester. This is from lecture number 5, if I am not wrong. Okay? Then the second one, we have this compound, this disulfide. We are treating with sodium borohydrate, and basically what we are doing is breaking this bond, okay, and we are forming two of the thiols. Okay, remember that from here to here is oxidation, from here to here is reduction. We are increasing the number of hydrogens, and basically we break the sulfur-sulfur bond and we put a sulfur hydrogen bond. Okay? Good. We go for the exercise number 2. Basically, it's know the mechanisms of the following reactions. We have this reaction, and we add hydrogen over palladium. Okay, how is working this reaction? Remember the palladium surface. We have here the palladium surface, and then the hydrogen is coming, and what we have is that the hydrogen is absorbed over the surface of palladium. And then what is happening is that okay, okay, the double bond, the alkene, with the p orbital going in the direction of the surface is coming, and what is happening is that we are forming these carbon-hydrogen bonds. Next step, we deabsorb this, and what we have is the two hydrogens bonded to where we had the double bond, and the surface free of hydrogens to take new hydrogens. Okay? This is how it's working. Okay? Good. Second one is basically we have a reduction, but this time is of an ester. We have this. And we are transforming this with lithium aluminum hydride in ethanol. Okay? What is happening? Remember, we have this compound. The bond that is forming the aluminum hydrogen bond is attacking the carbonyl compound. The pair of electrons that is forming the double bond between the carbon and the oxygen is going to the oxygen, and we have this intermediate. Okay, I will put the hydrogen that is coming from the lithium aluminum hydride in red. Okay, whoops, this is a mistake, sorry. Okay, when we have this, basically what is happening is that we have, this is the tetrahedron intermediate. Remember the lesson of the carboxylic acid chemistry. We regenerate the double bond between the carbon and the oxygen, and the leaving group, this time the ethoxide, is leaving to form okay. When we have the aldehyde, this aldehyde can be reduced again for the aluminium hydride. We put another molecule of aluminium hydride, and what is happening is again the bond that is forming the aluminium hydrogen bond, the electrons is attacking the aldehyde. Again, the pair of electrons that are forming the double bond are going to the oxygen. What we get is this intermediate. Okay. And now the last step is we protonate in a workup, and what we get is the alcohol, the ethanol. Okay? Good. Then we go for exercise number 3. They say explain the different behavior of these two compounds. Okay? Okay, here we have a secondary alcohol and a primary alcohol. Remember that when we oxidize one compound, what we are doing is replacing one carbon hydrogen for a carbon heteroatom bond. It means here what we have is here we have a hydrogen in this position. We have 4 substituents, methyl, OH and hydrogen. That means we oxidize this, we remove this hydrogen and we generate the ketone. However, when we have the ketone, this carbon doesn't have any more protons. I mean, we cannot, using this method, we cannot oxidize ketones because basically we don't have any hydrogen here to remove. That means that this is the final product. We cannot oxidize more this compound. What is happening with the alcohol, with the primary alcohol? Well, here we have 2 protons, okay? In the first case, what is happening when we oxidize alcohol, what happens first is that we remove 1 proton, and what we get is the aldehyde. But now, this is the first oxidation, now this aldehyde, this carbon of the aldehyde, has another proton. That means that we can oxidize again, because now this carbon has another proton. We can remove the proton and we can add a carbon-oxygen bond. Okay? And this is the reason why the final product in the primary alcohols is a carboxylic acid, while the final product of secondary alcohols, when we oxidize, is a ketone. Okay? Right? Okay, and the last one. The last one is define what process is each reaction, what we are doing in each reaction. Okay? Okay. Well, what we are doing here. First, we have an aldehyde, and this aldehyde is transformed in a carboxylic acid. We can consider that this is aldehyde, oxidation state 2 of this carbon. Here we have oxidation state 3. That means that this has to be an oxidation. Okay. We also can say that here we have a carbon hydrogen, and here we don't have any carbon hydrogen. We decrease the number of carbon hydrogens. That also leads to the oxidation. Next, we go here. This is a carboxylic acid, and we are transforming in alcohol. That means oxidation state 3, oxidation state 1. This is a reduction. However, we can show it in another way. Here we have a carbon-oxygen, carbon-oxygen, carbon-oxygen. We have 3 carbon-oxygen bonds. While here we only have 1 carbon-oxygen bond. That means we are decreasing the number of carbon heteroatoms, also leads to a reduction. Here we have a sulfur bonded to another sulfur, while here we have a sulfur with a hydrogen, sulfur with hydrogen. That means going in this direction, we are increasing the number of sulfur-hydrogen bond. That means this is a reduction. And here we have this compound, that this carbon has 2 carbon-hydrogen bonds, while in this case, here we only have 1 carbon-hydrogen bond. Again, this is a oxidation. Okay, why? Because we are reducing the number of carbon-hydrogen bonds, like here. Okay? Please check the answers at home. If you have any doubt, send me an email. I will be happy to answer any question. And this is our last lesson. Study. You will see that the exam will not be very complicated, at least not my part. And good luck!